topic today is to solving the parking challenge and enable smart city. In the smart city, people are living together. Why do we live in the city? Because of convenience. And in the city, we are communicating and working together with each other. And then the economy will go up faster in the city. But there are some limitations when we have cities. One of the limitations is the allocation of resources, because we have limited resources. So the smart city is to use the new technology to solve or to better allocate our limits or resources through the big data, IoT, or we call the communication technology. And there are some initiatives of the smart city. For example, the mobility, energy, education, and healthcare. Today, we will talk about the mobility, and the car parking is part of the mobility. And this is our agenda. We will talk about parking challenge in the city and the future requirement. We don't know what will be the future, but we know and we predict what the future needs, and then what the automatic parking system can solve the problem of the parking challenge and fulfill the future smart city requirements. And we will tell you, or we can share our experience with you, different type of automatic parking system we call APS. How can they have better space efficiency, and we can park more cars with limited space. And following, we will have the case sharing session that we will have 2 cases today. We hope these 2 cases to give you some idea how the automatic car parking system can solve the problem or solve the pain you have, and you may have the opportunity, the business opportunity with the cases of your projects. And last session is the Q&A, and as I mentioned, we will have the Q&A session. I just start to receive some questions, but if you have other questions, you can just put in the chat with our organizer, then we will answer your questions. I have the colleagues here and engineers and some technical experts to support this event. So if I cannot answer your question fully, then they will assist me to do it. First of all, when you are driving, then what will you do? Before you start, you will plan your route, is it? Then you will plan your driving time, how long it is to drive from your home or from your office to a customer location. And when we plan our route, then we will go to the Google Map and then check the distance. For example, if you are in New York, you come from Long Island to the World Trade Center of New York. So in the Google Map, how long it takes you to drive from Long Island to the World Trade Center? Basically, different type, in the peak hour or off-peak hour, you have different driving time. And roughly maybe 1 or 2 hours, 1 to 2 hours. So if you find in the Google Map, you take 1 hour, 30 minutes to drive, then you will leave home by 7:30 and arrive your customer by 9 o'clock. Is it correct? Yeah, somebody do that, but I don't. Because if you are in New York, you will have problem to find a parking space, and you will spend some time to look for the parking space. So you will need to add the parking searching time in your route planning. So Google Map does not tell you how long you take to search for a car parking space. And then it depends on your experience. And in this diagram, you see this driver is very excited because he is driving around New York. And the driver every year, a driver spends 107 hours to search a parking space in New York. So the problem is you don't have parking space. How can we solve this challenge? One of the way is to stop driving. If you don't drive, I mean less cars in the road, and then you will have you are more easy to find a parking space. The other one is to give more space. So we have two options basically, or you may have 3 or 4 options in the future. But today, if we are making a decision between 1 and 2, then I have talked to a lot of people, especially for the test driver. They will tell me, they always tell me, I will prefer to have less cars on the road, because if less traffic, they will drive faster and they earn much more money. But last week I got a call from my friend in New York. He is a retired a civil servant in United States, and he's like a test driver. He told me in New York, when there's low traffic, he earn much less money. You can see these two pictures. The left-hand side is the normal traffic in the Bay Beach, and the next side is the traffic in March Bay Beach. If we don't have traffic, I mean we don't have cars, then what will happen? Why don't we have cars? The most related research results show us that the number of cars or the number of traffic in a city is directly related to the economy or economic activities of this city or this country. So you will find that when the country is getting health, or their economy is getting up, then they will have the traffic jam in most of the cities, and and people will own more and more cars. That reflect their quality of life. So our solution may not be the first one, I mean less cars, but the second one, to create more space. So in case of creating more space, what will be the future requirements? As we don't know what are the future, but we predict from our experience of today, we want to have more parking space in the limited area of the city center or in certain areas. Another one, we should provide a convenience and safe parking experience. I mean, the parking space should be safe and convenience, I mean close to their place they want to go. And also, we also expect that the parking space information should be available to the drivers in real time. That is the 3 foundation of the future mobility. And you can see what we are doing today to solve the parking challenge. That is the video. So our technology in Singapore, how the driver can park their car and with limited space, but with good experience. The driver just stopped their car in the cabriolet. And we call the cabriolet, that's the transfer area. There is a lot of smart sensors inside the transfer area to ensure the safety. After the driver leaves, then we have the robots. The robots is working with human. I mean, they help us to finish our task, to put the car in the particular parking lot. Because the robots, they are intelligent and communicating with each other. So you see robots are moving together inside the car park smoothly and safely. And the cars are parked in the space while you are going to your customer or going to a shopping mall. And we have different type of robots. This one is the pilot type. the car is located on the pallet. The robots are moving continuously and under the cars, and then when you have to retrieve your cars, then you can use your mobile phone, and then your mobile phone will issue a task to the robot, and the car will be delivered to the transfer area that ready for you to pick up. That is the technology we are doing today, and we have more than 30 projects completed globally in Asia and other countries. Now, the robot is one of the technology we are using, but we will talk about what is the principle of the automatic car park system. Now, this is a conventional car park pictures. On the left corner, you see there are ramps. When there is a ramps, the ramps is allowing the car to transfer from a level to the next one. So in a conventional car park, we have a lot of space used by the ramp. The next one, when the car are driven by the driver, they need the space to turn. So the turning space is another area, other space used. We have the ways, the walkways or the passenger lifts for the drivers and the passengers to leave the car park. That is the additional space. Also, when you are inside the car park, you will observe that there is headroom spaces that is not used in the car park. That is another waste of the space. On the other hand, the cars are parked, but passengers and drivers has to open the door to leave. So we normally give 500 to 1,000 millimeter space for them to leave for safety and convenience. These are the spaces we can use in the automatic car park, and then you will have more parking space. The first one, we are talking about the semi-automated car parking system. That's two systems. Some of you may have used that, and you may have that in your city or even at your garage. This system is simple and easy to install, and they will use the headroom of your car park, and then they will put one more car on the top of it, and then with a very low cost and short installation time, you will have a space for additional car. And you will observe that there from the picture, this is particularly useful for the the built car park. I mean, if you already have a car park, they have sufficient headroom space, then you can install this system, and then you will get more space quickly. The other one is the fully automated parking system. You can see this is an example of the fully automated parking system. We have more than 10 proposal setup of the automatic parking system. This is a standard one, and then you can see there's a lifting system, a lift. The rails to guide the shuttles to be moving, and we have the dollies. We have the other components. I mean, the sensors and the communication components. And most important, we have the tablet. Tablet is the transfer area. And the right-hand side, you can see that there is a tablet, typical example of our tablet that was built 3 years ago. And then the driver just drive the car into the tablet, and he will have the instruction. He will know whether his car is stopped at the correct position, and then he will get out of the tablet and then confirm there's no people left behind. I mean, inside the car, and then the sensors will detect the motion and the dimensions and help the driver to park the car safely. This one, as you can observe, is suitable for the new built properties rather than existing car park. The investment is more, but you get a safe and convenient parking experience. If you are focusing on the customer experience, then this one may be your better choice. Now, we can go to some examples. How can we increase the parking space, number of parking space? This is a conventional car park, 80 meters times 34 meters. In our regular design, we can put 27 cars inside this area. There's a flat ground area. We don't have the ramp, we don't have the stairs, something like that. So you can put 27 cars. If we put the simple semi-automated parking system, then you can put 38. There's 40% increase of the parking numbers. But you may also observe that this type of semi-automatic parking system, they need more space for the turning radius. So you will observe that you may not get the same number of cars at the base. Maybe reduce a little bit to give the driver to park their car safely on the system. And that is the way the semi-automated parking system is decided. And that is a traditional fully automated parking system. You can find that this one is not many levels, because you are not allowed to build many entrance points, the cabinets on this system. This is particularly useful for example, you can use it in the under the playground or under a building. The ground floor you can be used in other purpose. You just get the space for the driver to park their car into the cabinet. This is another type we call more levels you can achieve. Because of the design, you can build more entrance, the cabinets in the system. It gives you a faster, quicker turnover of the car numbers, and you can reduce the waiting time when there is peak hours. The third one, that's the other typical one, is the tower parking. This tower parking is a tall building, you can imagine, but it's good because it can increase the number of cars by 3,000%. 31 times number of cars in a very small footprint. But this car park is tall, so you may have to consider whether that will affect the environment of the neighbors. But it has the advantage because if it's tall, it can be a landmark of your city, or you can have some other features to use this tower to drive your income. For example, you can do the promotion or exhibition on this tower. Now we will go to some case sharing. The first one, that is an underground car park. This is a PPY car park, as I mentioned it before. This is the trailer vocational tourist attraction. And you can see from the picture, there's a large relaxed area, and the people come here to enjoy their holidays. Every day there are 20,000 people comes here, and there's a traffic pressure. Traffic when the people comes, and when we have the inquiry, then the property owner has some requirements. They require 1,800 parking space. They require a safe parking process, and the driver should be convenient. I mean, they should be parked and then go to the this recreation center easily. So the car park should be located close to the main gate of the property. But the car park should not occupy the ground floor space. It means that you cannot build it on the top of the ground. So it should be underground. And it should be matching with the environment. So you cannot destroy the landscape, and then the people cannot, I mean, the eyesight cannot pick your car park easily. So we just put the car park in an area that people do not observe it easily. So that is the site of our car park. You can see in the picture, there are cabinets. We have 26 cabinets. These are the only building, I mean the only construction on the ground level. And below there, in the red hidden line, there is the underground construction of our PPY system. And we also design the traffic, how to prevent the traffic jam. I mean, when the car comes in and out, they don't need to wait for the other drivers, and to maintain the smooth traffic flow. And we also design some restroom or the waiting room for the drivers. When they are collecting their car, they can wait inside the waiting room to wait the car to come out. And it's the appearance. If you come to our car park, then please come, and then you can see that we use the material. We use the roadside. We tell you how many spaces available, and indicate you where is the suitable entrance point to you, and then you can easily go in and out because the design is drive-through. Some of them are mainly a drive-through. The driver just drive in from one direction, and then he leave and the other one. And that is a safe design. And internally, you can see we have the cabinet and the ground floor. Mainly, they are drive-through. And the lift, we have 25 car lift to transfer the cars from the ground floor to the parking levels. And we have the shuttles. We provide 1,806 parking space. The objective is the efficiency. We provide high efficiency of transport, collection and parking. It's convenience because it is close to the entrance, and the safe and the speed. And you can see our layout inside. We have the turntable cabinet, and we have the drive-through cabinets. We have different design of the cabinets and the lift system because we in our proposal we will have some limitation of the environment. So we will put the suitable technology into the system. So when you come to our car parking system, you will find that we apply different type of technology or integrate different type of technology into the car park, and to make it most efficient and suitable for the customer. The other one is the robot. Before I go to the case, I show you the family of robots we are using. And you can see we have the different types of robots. Some of them, they need pallet. Some of them, they need supporting fixture. Some of them, they don't need anything. They just stop the car, and then the robot will pick the car and then transfer to a particular area. And we will have the new developed robot, then they can park in multi-levels. Our example is the Robertson Tower in Singapore. This car park has already been used last year. And then if you come to Singapore, you will find that this is a commercial center. And the customer, they have the requirements. They have limited space because of the land price. They don't want to use the ground floor or the ramp for the car park. And our car park is decided in the basement. And then the basement, the footprint is also very small and not regular. And if you drive in with a traditional RAM car park, then you will just park a few cars. But with our design, we created a 90 parking space, underground 5 floors, and the car can be moved in any direction with our AGV. And then and at the same time, the customers, they can use the apps when they leave. They use the apps to call the car, and the car will be ready for them to pick when they leave our car park. In here, in this project, we particularly want to let you know that this AGV car park is very flexible, because in the initial design, we only design 85 parking space, but the customer need more, and then we can build more because the AGV can move the cars in another way, and then they will increase the number of parking space as need. And also, when the customer also increase the dimension of the car when we are implementing this car park, so we can adjust the components and the computer system, and then we accept the extra large vehicles in this car park. That is a particular a benefit for the customer, because they will change their requirement by the way we are building the car park, and this one give them the flexibility to do that. And the other traditional car park, I mean the traditional automatic car park, they may not be able to change as much as it is. So before the end, we will hope to let you know that we will have the coming webinar in the next coming months, and we will choose the topics, which one is most suitable for you. So please tell us which one you want to know. I mean, which topic you are more interested, and then you let us know in the survey, and then we will make the topic presentation in the next step.